Welcome to the ArchiCAD 15 Design Webinar. In this presentation, we will demonstrate how ArchiCAD helps designers with revolutionary new tools and methods to unleash their creative minds. First, we will give you a brief overview about challenges related to model-based design. Then, we will demonstrate ArchiCAD 15 live, concentrating on innovation in the design workflow. At the end, we will dedicate time to questions and answers. So that being said, let's start now. Enjoy the show. It is worth noting at the beginning of our demonstration that ArchiCAD is, in fact, the widest localized BIM solution for architects worldwide. This means that it is not only translated into 17 languages, but it is actually available fully localized to 25 national standards in 100 countries. Moreover, it is the only true BIM application running natively on both the Apple Macintosh and the Microsoft Windows operating systems. Now let's see what ArchiCAD 15 has to offer architects and designers. Architects and designers have always longed for design freedom, to go beyond the regular orthogonal shapes to break out of the box of vertical walls and horizontal slabs. The best examples of classical and modern architecture all contain curved surfaces in some shape or form. Design tools, however, don't always ease the realization of such forms. In our webinar, we will concentrate on some of the challenges architects encounter when trying to design and document buildings containing freeform structures. The evolution of the design process has gone through at least as many revolutionary steps as the forms and structures themselves. First, there was paper and pencil, with which designers could enjoy ultimate freedom in all senses. Whatever you could imagine and document on paper had the potential to become actual buildings. Your design tools didn't impose limitations, but they didn't provide any support to create your design either. This fundamentally changed with the introduction of computer-aided design. There, you either tried to work out your design with 2D drafting tools and independent 2D views, or you could choose to start with conceptual design and separate mass modeling applications, and then later switch to your CAD environment to do the documentation. The problem here is not only the abrupt workflow, but also the complete lack of actual building characteristics in the generic modeler applications. Although BIM, the next evolution in the building design process, brought along the promise of integrated model-based design, the vast majority of design steps are still carried out in 2D views, using the model only for visualization and coordination. Paradoxically, due to this phenomenon, BIM today provides more help for designing freeform buildings than traditional 2D CAD. You may wonder about this paradox. Stay tuned while we continue with the very reasons for utilizing the full 3D capabilities of BIM. In any BIM tool, in order to provide full support for design freedom, you need three basic things. First and foremost, you need tools capable of creating freeform structures. Some BIM tools provide some freeform tools today, but no BIM tool offers a fully integrated workflow to start creating freeform BIM elements from the initial concepts and carry those structures through to the very end of the design and documentation workflow without any conversion. Last but not least, creating freeform structures, as we noted previously, is barely possible in 2D views. What you need is full editing support of your freeform BIM tools in any views, including the 3D perspective views. Now let's see how ArchiCAD 15 introduces fully BIM integrated freeform design tools and a revolutionary new approach to designing freeform structures in 3D. Looking at classical and modern architectural landmarks, we soon realize that 99% of those buildings are in fact composed of some basic shapes. ArchiCAD 15 introduces the brand new Shell tool that supports the design of a wide range of architectural shapes, including revolved, extruded, and ruled geometries. In the coming live demo, we will show you some real examples where the Shell tool is being used to recreate some classical architectural forms. Obviously, the shell tool is only worth its weight in the BIM world if it's fully integrated to the design workflow. You will see in the demo that in ArchiCAD, the design starts with real BIM structures from the very first step, and provides that even fundamental changes to the conceptual model will not require restarting the documentation every stage. We discussed that creating freeform structures in 3D would be the natural place. At the same time, 3D compared with 2D introduces such a level of freedom in space that finding your way may be extremely difficult. 3D, no question, is the right place to understand, create, and manage the connections between complex building structures. 3D has an additional problem, too. Due to the possibility of place elements off the XYZ coordinate system, accurate editing may be extremely difficult. ArchiCAD 15 introduces innovative tools such as the 3D guidelines and 3D editing planes to turn 3D into the natural space for accurate modeling of freeform structures. Let's proceed and switch to ArchiCAD now and have a closer look at all the previously described design concepts and workflows in action. Let's see how we can find directions and work accurately in 3D. On the screen, you can see the version number of ArchiCAD 15. We will reproduce this number using 3D guidelines. Let's start by having only this segment of a circle. We should find the vertical and horizontal directions in 3D in order to continue. Let's switch on 3D guidelines, which are now available not only in the orthogonal plane, section, and elevation views, but also in perspective 3D views. Using guidelines, we can instantly find the main X and Y directions in any 3D view. Let's start by creating a straight wall segment. As you can see, a temporary guideline appears that automatically snaps to the main Y axis. The letter of the main axis is also displayed on the guideline. In this very same way, we can easily locate the main X direction as well. This works the same way on the floor plan view. After creating a wall along the main Y direction in 3D, let's continue and create another wall segment, which is tangential to the circle segment. Here we will need some additional temporary guidelines. We can create a circular temporary guideline by moving the mouse over the existing outer perimeter of the circular wall in 3D. Please note that there is an orange dot on the guideline. By clicking on this dot, we can activate the guideline. This is important because by doing so, designers are able to keep only the needed guidelines, even in cases of complex design situations or multiple elements. Now let's find the main Y direction by moving the mouse over the previously created straight wall segment. The temporary guideline appears with the orange dot. This dot can also be used to reposition the temporary guideline in the 3D window. Instead of clicking on the orange dot, we will grab the guideline at the dot and change its position in 3D. We will move the guideline to a tangential position to the previously created circular guideline with the help of the smart cursor. Now we have all the guidelines we need to create the additional straight wall segment. Once we start to draw the new wall parallel to the main X direction, we can use the previously locked guidelines to create the necessary wall length. Now the number 5 is complete. Let's continue to add the number 1 in front of the number 5. We will use the very same circular guideline as we did before. We will move the guideline parallel to the Y direction to tangential to the circular guideline. Now we also need another guideline parallel with the main X direction. We will move this tangential position with the circular guideline. We will need to fix yet another guideline parallel to the main X direction at the top as well. Now we have all the guidelines needed to create the number 1. As you can see, we have created the number 15 in 3D with the help of 3D guidelines. Let's see how we can use editing planes in 3D views. Here, our task is to reproduce the transparent blue slab at a given height surrounded by these walls. Please note that one of the walls is slanted. The new blue slab must be in projection to the existing white slab. Currently, we have only 2 intersecting walls and the upper slab. First, we have to know where to create the new slab. For this, we need to display the editing plane at the proper height and location in the 3D view. Let's display the View, Grid Options, Grids and Background dialog. Here we can adjust the color of the background, as well as the grid lines of the editing plane. As you can see, the 3D editing plane, by default, is displayed at the position where a new element is about to be placed. In this case, the Wall tool is active. If we open the Wall Settings dialog, we can see that the default wall base is located at the level 0. Therefore, the editing plane is also displayed at the 0 level in the 3D window. However, now we would like to create a slab at a given height above the 0 level. Let's activate the Slab tool. Please note that the level of the editing plane has changed as well. The position of the editing plane instantly changes to reflect the position where the base level of a new element will be created. Here you can see that the default slab height is at 4,000 millimeters above the 0 level. We'll create the new slab at this level. Now we need to find the projections of the outer contour of the slab above this editing plane. Let's display a temporary guideline along the edge of the existing slab. We can hold on to this 3D guideline by clicking the orange dot. We can freely create and reposition guidelines in 3D views. Please also notice that the projection of the activated guideline instantly appears on the editing plane below, represented by light blue. This greatly helps all 3D element creation and editing. Let's create another guideline along the other edge of the slab. The projection of the new guideline is also displayed in light blue on the editing plane below. Let's continue and define the intersections of the walls in the editing plane. This does not require any additional guidelines. Notice that snap points are available at the intersection of the editing plane and existing elements. This ensures precise element creation and editing even in cases of elements having curved, slanted, or profiled geometry. ArchiCAD Smart Cursor instantly indicates the intersection lines and points as soon as we start creating the new slab. The slab can be completed with the help of the previously created projected guidelines. Since we are editing in perspective view, it is not obvious that the slab edges are located along the same vertical position. Let's verify this by connecting the slab edges with a vertical column. Let's open the Column Settings dialog and set the base height of the column to 4,000 millimeters. Let's create a new column starting at the edge of the lower slab. As you can see, the top of the column is located exactly at the edge of the upper slab. This proves that the newly created lower slab is in the vertical projection of the upper one. ArchiCAD provides not only 3D guidelines, but also helps you find your way and survey the position of all elements in perspective 3D views. For instance, if we select all these walls on the new slab, you can see that the hidden element parts are shown in a lighter surface color and a dashed line type. The visible parts of the selected elements are shown in a brighter surface color and a continuous line type. The reference lines of the walls are shown in blue, while the other edge lines are shown in green. Let's now see how we can change the orientation of the editing plane to help the creation and editing of elements located in sloping or inclined directions. Here you can see 3 roof planes in perspective view. We want to create an opening in the roof with given dimensions using different construction methods. First, we'll create an opening with given dimensions measured in the roof's plane. Let's switch on Grid Snap, and let's also display the tracker to help our work. Let's activate the Roof tool and select the first roof. As soon as we start to create the opening, the editing plane instantly moves to the top surface plane of the selected roof. Now we can use the construction grid and Grid Snap, as well as the tracker palette, to enter the desired dimensions of the opening. Let's move to the second roof. Here we also want to create an opening, but in this case the dimensions must be measured in the vertical plane. Let's select the roof and start creating the opening. As you can see, the editing plane moved to the plane of the roof as before. Please notice the blue icon in the editing plane. By clicking on this icon, we can change the orientation of the editing plane. Let's change the orientation of the editing plane to vertical. Now we can use the same construction aids to define the exact sizes of the opening. Please notice the dashed lines, which are the projection of the opening to the plane of the roof. Now the second opening has also been created, and its dimensions defined in the vertical plane. Let's move to the third roof, where we must create an opening with given dimensions measured in a horizontal plane. We will use the blue icon in the editing plane to switch it to the horizontal position, and use the tracker in the construction grid to define the required dimensions for the opening. ArchiCAD provides a 3D design environment to help architects create and edit elements in 3D view with high precision and in an easy manner. This greatly reduces modeling time, while it also enables designers to develop design ideas in 3D perspective views as their native design environment. ArchiCAD 15 expands the design capabilities of its BIM tools, including new shell structures, to support the broadest spectrum of architectural shapes and forms prevalent in both classical and modern architecture. ArchiCAD offers 3 types of shell structures: extruded, revolved, and rules shells. Let's have an overview of extruded shells. This building represents the trends in contemporary architecture. It's not always easy to clearly distinguish between the roofs and the walls of contemporary buildings. For designers, however, it is important to create and edit these freeform shapes in a quick and easy manner. Let's start our design with this conceptual building volume. Let's activate the extruded shell geometry method and the detailed construction method. First, we will define the editing plane. Let's use the vertical surface of the building volume for the editing plane. Now we can start creating the profile of the extruded shell in this vertical editing plane. As you can see, the PET palette provides various options to complete the profile of the extruded shell structure. We will use the combination of straight and curved line segments to create the shell profile. We can close the definition of the profile polygon by double-clicking the last point. Now we will define the extrusion length. Certainly, this is not the final extrusion length. Let's extend the extrusion length towards the other direction as well. We can do this by clicking the edge of the shell. Let's activate the Edit Extrusion Length operation of the PET palette to modify the extrusion length. Now we will adjust the extruded shell up to the base slab of the building. Let's select the shell and activate the Define Shell Contour operation from the context menu. We will hold down the space key to activate the magic wand. And now we will use the magic wand to trace the contour of the existing base slab with a single click. Now the extruded shell has been created. Let's continue and adjust the shape of the building volume to the shell. All we need to do is select the building volume and activate the Connect Trim Elements to Roof Shell command from the context menu. Note that the shape of the cursor changes. Now we will define the trimming body, which is the extruded shell. ArchiCAD provides very accurate visual feedback on the result of the operation. The cutting body of the shell is displayed in red. The remaining mass is displayed in blue. Surely we do not want to keep the upper part. We will keep the lower part of the volume, so we will click on this part. Now the unnecessary part of the building volume has been removed. The previously established connection between the shell and the volume is fully associative. Practically, this means if we modify the shape or the geometry of the shell, the shape of the connected volume will be updated instantly as well. Let's modify the geometry of the shell profile polygon with the help of the Pet palette. As you can see, the building volume will also be updated automatically. There is no need for any manual workaround. Let's proceed and add some openings to the surface of the shell. ArchiCAD's Skylight tool enables designers to add skylights not only to the roofs, but also to any type of shells. We can place the skylights in the 3D view. All we need to do is click the surface of the shell to insert an opening into it. We can insert openings into any part of the shell surface in the very same manner. The openings can even be located across segments of the shell. This was a short presentation on how to create extruded shells with ArchiCAD. Let's proceed and create ruled shells. We will create the canopy of this stadium with a hyperbolic structure. Let's start the design by having only these slanted walls and this rectangular wireframe block to speed up our work. Of course, we could use any other construction aids or elements to define the geometry of the vertexes. Ruled shells are created by two work planes and two profiles. First, we will set the work plane with 3 clicks on the wireframe object, and then we'll create a very simple straight profile. Later, we'll repeat this on the other side of the wireframe object. Let's select the Shell tool and activate the Ruled Shell Geometry method. We will start by defining the editing plane for the first ruled segment. We will define the editing plane with 3 points this time. We will use the vertexes of the wireframe block to define the editing plane. Once the editing plane is set, we can define the first profile in this plane. For this occasion, we will use a simple straight line segment for the profile. Let's continue and define the other editing plane on the other side by the vertexes of the wireframe block. Here we will also define a straight line segment for the other profile of the ruled shell. As you can see, the hyperbolic shell surface has been created. Let's proceed and adjust the perimeter of the shell structure and also cut a hole in it to provide daylight for the stadium. Let's switch to the floor plan, since we have already created some construction aids here defining the perimeter and the hole. These are simple polylines that we will use to cut the ruled shell structure. Let's select the shell on the floor plan view. We will activate the Define Shell Contour command from the context menu to adjust the contour of the previously created ruled shell. With the help of the magic wand, we will trace the polyline, and with a single click we can cut and remove the unnecessary part of the shell. We can also create a hole in the very same manner. Let's activate the Create Hole in Shell operation from the context menu, and then use the magic wand to trace the inner polyline to define the shape of the hole. Let's switch back to the 3D view. The shell structure is almost perfect now. We will connect the slanted walls to the surface of the shell. First, we'll select all the slanted walls in the 3D view. Now, we'll activate the Connect Trim Elements to Roof Shell command from the context menu. We will select the shell itself. Notice that its representation turns to red. Now we select the slanted walls and highlight the lower parts of the walls since we wish to keep this after the trimming operation. The ruled shell structure is ready. Please note that the shell modifying operations are fully associative. For instance, we can change the straight profile of the ruled shell to a curved profile with the help of the pet palette. As you can see, the trimming of the slanted walls has automatically been updated, and these are still correctly connected to the surface of the new shape of the ruled shell. Indeed, all elements are fully integrated with the ArchiCAD BIM project. As you can see, all the floor plan views of the stadium are automatically generated and always updated. Let's continue and see how to work with revolved shells. We will create a revolved shell structure to connect these two existing buildings. Let's switch to the floor plan view. Here you can see the two existing buildings and a polyline to speed up the work. Let's activate the Shell tool and select the Revolved Geometry method. We'll use the magic wand to trace the geometry of the polyline and use this for the profile of the revolved shell. With the next click, we will define the axis of the revolved shell. We can manually enter the revolution angle. We will use 180 degrees for the angle this time. Let's switch to the 3D view to investigate the results. We will proceed and distort the shell to fit better with the existing buildings. We will select the shell and use the distort operation from the pet palette to distort it. As you can see, the 3D view of the shell has been updated. Let's proceed and modify the surface material of the shell to represent its structural scheme. We would like to indicate that this surface will be constructed using a structural steel skeleton. As you can see, the 3D view has been instantly updated with the new surface texture. Using the Shell tool, designers can not only create building structures, but they can also use these to create interior design elements, furniture, and objects. Here you can see a designer chair created with the help of the shell structures. Here you can see a fruit bowl and some apples. Not only the bowl, but also the apples are made of shells. The ArchiCAD Shell tool supports the creation of a broad spectrum of architectural shapes for building structures that are prevalent in both historic and modern architecture. These shell structures remain an organic part of the entire BIM workflow without the need for conversion at any stage of the process. Accurate element schedules, floor plan, section, and elevation representations are natural outputs of a true BIM project. Thanks to the advanced 3D design environment of ArchiCAD, architects can use familiar interactions to enjoy an instant design experience. Designers can create complex roof shapes with multiplane roofs in a simple and easy manner. Here you can see the completed building, consisting of 3 main volumes: a pool, a fitness center, and a service area connecting the previous two. Let's see how we can create a unified complex roof system to cover all three volumes. Let's have a quick look at the roof settings dialog. Here you can adjust all the different roof settings, multiplane geometry, eaves, overhang, inclination angle, and so on. We will do all the work in the 3D environment in perspective view. Let's select the Roof tool and activate the multiplane construction method. We will use the polyline geometry method to create the pivot line of the new roof over the pool area. ArchiCAD's intelligent cursor changes its shape to provide feedback when you find a vertex or a node in the 3D window. The pet palette is always on hand to provide construction and editing options to ease and speed up your work. By clicking the vertexes of the existing building volumes, we can define the pivot line with 4 clicks and create the new roof over the pool area. Now let's see how we can adjust the roof structure to fit the building mass. We can use the editing operations provided by the pet palette to curve the edge of the roof in seconds. All we need to do is click the pivot line of the roof, choose an operation provided by the pet palette, and complete the editing with the help of the intelligent cursor. Please note that the curved roof structure is still a single structural system. Let's continue and add a new roof segment to the roof over the entrance area in the previously described manner. After selecting the Add New Roof Segment option from the pet palette, we can define the new segment by the top vertexes of the existing building volume. The new segment has been automatically added to the roof, and the roof remained a single integrated structural system. Let's switch to the floor plan view. Please notice that the floor plan representation of the roof is automatically completed. There is no need for any manual workaround to complete the floor plan view of the roof system. Let's create the courtyard in the floor plan view. After selecting the roof, let's choose the Remove Segment option from the pet palette. This time we will use ArchiCAD's magic wand to automatically trace the inner perimeter of the yard. As you can see, the floor plan view has been automatically updated, and it already reflects the roof modifications we've just completed. Let's switch to 3D view now to investigate the results. Please note that all the roof planes are still connected and handled as a single roof system. Let's proceed and add roofs over the 2 corridors. The additional roof systems can be added in seconds with the help of the pet palette and the magic wand. The roof structures can be successfully used at the early schematic design phase. Since their representation is automatically created and updated in all the other section, elevation, plan, etc. views, these automatically generated views are also great help at the construction documentation design stage. As you can see, the roofs in ArchiCAD can have complex shapes, yet they represent a single roof system. At the same time, all the roof planes and roof segments can be edited individually, while also keeping the overall roof structure as a single integrated system. Let's select the roof, click a roof edge, and activate the Custom Plane Settings option from the pet palette. Here we can define various settings, materials, curve resolutions, and so on for any individual roof plane. We can even change the roof plane type from pitched to gable. As you can see, the effect is immediately visible in the 3D window. Let's do the same modification one more time for the other corridor as well. Let's proceed and complete the roof of the fitness center. Let's use the magic wand to trace the perimeter of the building volume and create a new roof in seconds. Let's proceed and add a new roof level to our new roof. Let's select the roof and open the multi-plane page of its settings dialog. Here we can add a new roof level and also adjust its pitch value. Let's use a 45-degree angle. The 3D window instantly displays the results of the modifications. The fitness center needs more light, so let's proceed to change some characteristics of entire roof levels in a single step. Let's open the Custom Plane Settings option of the PET palette again. We will change the material to transparent glazing. We'll apply the changes to the entire clicked roof level this time. The results are immediately visible in 3D. Let's create a roof for the service area and connect the two roof systems. We will create a slightly lower roof this time. The new roof can be created with a single click with the help of the magic wand. Everything looks fine from this view angle. But now let's take a look from below the roofs. You can see that the individual roof systems are not yet connected. The intersections between the roofs are not yet correct. Let's fix this with a single operation. We will select all the roofs and activate the Connect, Trim Elements to Roof or Shell command from the context menu. We will apply the trimming to all the roofs that are currently selected. As you can see, all the roof connections have now automatically been fixed. The best news is that all roof connections remain associative. For instance, if we modify the shape of any of the roofs, all the roof connections and intersections will be updated automatically. In cases of complex roof structures, it's important to survey these connections in a quick and easy manner. This can be done using this little icon. This displays all other systems connected with the selected element. By hovering the mouse over the different systems, ArchiCAD will instantly highlight the connected elements in the 3D view. The connections can also be turned on or off individually using this pop-up palette. Architects are not only able to create connections between elements, but with this local menu they can review and manage these connections through the entire life cycle of the project, including curtain wall and solid element operations connections. For certain, all the roof systems are fully integrated with the ArchiCAD BIM model. Element schedules as well as quantity lists can be generated automatically. The representation of the roof systems are also integrated across the project. Floor plan, section, and elevation views are always created and maintained automatically. Even the cut surfaces on the floor plan views are represented correctly. Indeed, if different floor plan views are displayed, the representation of the roof systems will also change automatically and accurately according to the actual horizontal cutting plane. The Roof tool of ArchiCAD enables designers to model even the most complex roof structures quickly and perform design changes and editing operations in a simple manner. The ArchiCAD Roof tool is not only a modeling tool, but also a very powerful design tool. Refurbishing existing buildings is also an important part of architectural practices. ArchiCAD 15 introduces native BIM design and documentation workflow for renovation and refurbishment projects. Let's now see the renovation design workflow provided by ArchiCAD. Here you can see a simple existing building. We'd like to create offices on the upper floor and an auditorium on the ground level. Let's display the renovation palette on the screen. This palette includes the most commonly used renovation-related tools. Here we can change the renovation status of the individual elements, and we can also switch between the different renovation filters. The renovation filter pop-up lists all the typical renovation project filters. Here we can display the existing plan demolition plan, after demolition, new construction, as well as the planned filters. Let's switch to the demolition plan filter. We can apply 3 different renovation statuses to individual elements, such as existing element, to be demolished element, or new element status. Let's proceed and demolish some interior partitions. First, we switch on the demolition filter and select some partition walls we want to demolish and change their status to be demolished in the renovation palette. Their color will immediately change to yellow to reflect their new status. Let's select some additional elements: furniture, openings, and stairs. With a single click, we can change all their statuses to be demolished. Let's switch to After Demolition filter. Notice that now all the previously demolished elements have disappeared from the screen. Let's switch on the New Construction Renovation filter. Here you can see the previously demolished structures, partitions, openings, etc., because this will help architects create the new elements. Please notice the red infills in the walls at the location of the demolished openings. ArchiCAD automatically created these as new construction elements because the demolished openings need to be filled in. Let's create a new partition wall at the entrance area. We'll change the status of the wall to New. We can switch on the New Status button in the Renovation palette, so all newly created elements will automatically be assigned with this renovation status. Let's insert some doors into the walls. We will also insert an entrance door in the external wall. Let's add some furnishings to the auditorium area. We will insert an intelligent seating object. We can place this object with a single click. Let's select it. With the help of its editable hotspots, we can quickly create the appropriate number of seat rows and columns to fill the auditorium area. The creation of the new construction is ready. Let's switch on the Planned Status Renovation filter. Here, only new construction is visible. All this looks great in floor plan views. Let's see how the renovation views look in the 3D view. Here you can see a 3D cutaway of the existing view of the ground level area. Let's switch on the Demolition Plan filter. You can see that the color of the demolished elements changes to yellow. Let's switch on the New Construction filter, where the elements are displayed in red and the demolished elements in yellow. This visual color feedback provides great help not only for designers, but also for clients and engineers as well. Here you can see the project once the planned renovation filter has been switched on. Let's see how ArchiCAD supports local renovation standards. Let's activate the document, Set Renovation Filter, Renovation Filter Options dialog. Here you can see a large preview image displaying the selected renovation filters and element status. All the renovation filters are fully customizable. Here you can see a typical representation of a German demolition plan view. The contours of the demolished structures and openings are displayed by dashed lines. Norwegian renovation standards require that all demolished openings are displayed with an additional X sign. Such additional filter options can easily be applied to existing elements by selecting these from the list on the left. For instance, if we checkmark the Mark Objects with X symbol option, ArchiCAD will place an X sign over all demolished openings. Please also note that these filters can be saved with views in the view map and placed onto layouts to document the renovation process. Schedules by renovation status and IFC export are also available. ArchiCAD 15 expands the design scope to renovation and refurbishment projects with native BIM design and documentation workflow support all the way through. Ideally, building design is not an exercise on paper. The real result is the finished building. Now we would like to present to you how to use the impressive design tool set of ArchiCAD to model some architectural classics. The St. Francis de Sales Church of Muskegon, Michigan, USA was designed by Marcel Breuer in 1967. He mastered the art of combining sculpture and architecture and utilized hyperbolic paraboloid shells to enclose the body of the church and gave these warped surfaces the functional manner of becoming structural walls and frames. Here you can see the completed ArchiCAD model of this building. We will start on the floor plan view. We have already placed the base slab and two lines as aids to help the work. We will use the ruled shell geometry method and the detailed construction method to create the first ruled shell. Now we define the first polygon of the ruled shell. Then we set the distance between the planes of the profile polygons. Finally, we define the second polygon as a straight line perpendicular to the first one. Here you can see the shell on the floor plan view, and here it is in 3D. We have already created some 3D construction aids to speed up the work. We will use these 3D guides to create additional shells in 3D. The profile polygons of the ruled shells will all be straight lines. Let's see how to create the next ruled shell in 3D. We start by defining the plane of the first profile polygon. This is the upper plane of the existing slab below. Now we define the first profile polygon using the blue 3D guide. We continue by defining the plane of the second profile polygon of the shell. We define this plane with the help of the vertexes of the wireframe block above. Finally, we create the second profile polygon of the shell with the help of the green 3D guides above. The second ruled shell has been created. Let's continue and create 4 additional ruled shells in the 3D window using the previously described steps. Here you can see the result of the work in 3D. 6 ruled shells have been created. Let's switch to the floor plan view and notice that the plan view of the ruled shells has been created instantly. The plan view is the correct 2D projection of the actual 3D element. Let's open an elevation view. We will need to trim the shells to achieve the correct shape of the frames. We will use the red polyline to trim the first shell. We select the first shell and then activate the Define Shell Contour option from the context menu. We use the magic wand to trace the contour of the red polyline and use it as the trimming polygon. Let's proceed and trim the rest of the shells also in the section view. We will use the blue polyline and trim the shells one by one using the previously described method. Let's switch to the 3D view now and investigate the results. As you can see, the hyperbolic paraboloid surfaces we created in the first step with ruled shells became the structural frames of the building. Let's select all the trimmed shells in 3D and mirror them using the blue construction line for the axis of mirroring. Now all the main structural ruled shell frames are complete. Let's continue and create the external wall structure at the end of the shell skeletons. We will use another ruled shell to create this. We will define the plane of the first profile polygon of the ruled shell using the vertexes of this wireframe roof we placed previously as an aid. We create the first profile polygon along the linear edge of the first shell frame skeleton. We define the plane of the second profile polygon by clicking the vertexes of the other wireframe roof, and define the second profile polygon along the other external straight edge of the skeleton shell. Here you can see the completed enclosed structure created by a ruled shell surface. We will flip the shell so that the external surface is in line with the surface of the skeleton frame. The rest of the external surfaces can be created in a similar manner. Here you can see the building model with all 4 external surfaces complete. In this view, the roof of the building has also been completed. Please notice that the bell support structure on the roof was also created using ruled shell structures. Let's proceed and create the bells of the church using revolved shell structures. Here you can already see the axes and the profile of the bells. All we need to do is to activate the shell tool, select the revolved shell geometry, and detailed construction method. With the help of the magic wand, we can trace the profile polygon of the revolved shell, and we can use the blue construction line for the axis of revolution. We enter 360 degrees for the revolution angle. The first bell has been completed. Let's create the second bell in a similar manner. Finally, we will mirror the first bell using the axis of the second bell for mirroring axes. Here you can see all 3 bells in 3D. We will rotate the bells to their final vertical position using the free rotate command in the 3D window. In this view, you can see the bells in their final position. Here you can see the perspective view of the completed ArchiCAD model of the building. The rest of the building elements were also created by ArchiCAD tools. For example, the load-bearing structure of the gallery was created with the help of complex profile beams. The Chrysler Building is a well-known skyscraper in New York City designed by William Van Alen and built between 1928 and 1930. Standing at 1,047 feet, that is 319 meters, the Chrysler Building is a classic example of Art Deco architecture and considered by many contemporary architects to be one of the finest buildings in New York City. Here you can see the completed ArchiCAD model of the Chrysler Building. In this short presentation, you will discover how to use ArchiCAD's shell structures to create the top part of this skyscraper. In this 3D view, we have already created some polygonal walls. We will create the profiled arc of the tower on these walls. We will use revolved shell structure to create the arc. We set the profile plane to the top of the polygonal wall. Let's trace the vertexes of the wall profile to define the profile polygon of the revolved shell. Once the profile is ready, we will define the axes of revolution using the existing construction line in 3D. Here you can see the completed arc in 3D. Let's switch to the floor plan view and have a quick look at the floor plan view of the arc. Switch back to the 3D view again. Here we have already added a wall to the arc. We will adjust its height to the previously created arc. Let's select the wall and activate the Trim Elements to Roof or Shell command from the context menu. We will define the revolved shell as the trimming element and trim the wall to the arc. Here you can see the completed arc with the wall. We will create 3 additional copies with the help of the Multiply command in 3D. The result is 4 identical arcs in the 3D window. In this view, you can see the previously created arcs at the top of the skyscraper. We have already created the lower, simpler part of the building using simple walls, slabs, and wall openings. Let's continue and add the top part of the tower using ruled shell structures. We will start creating ruled shells on the floor plan view, and use the magic wand to define the first profile polygon with the help of the already placed elliptical line. The plane of the second profile polygon will be at a given distance of 1000 millimeters. We will use the magic wand and the existing guideline to define the second polyline. Let's proceed and create an extruded shell, as well as finalize the shape. We will use the magic wand and the existing construction line to create this extruded shell structure. And then we'll move this element over the previously created structure. Let's switch to the 3D view. We will rotate the shells to a vertical position with the help of the free rotate command of the pet palette. Let's proceed and create 3 additional copies of these elements with the help of the multiply command in the 3D window. Finally, we will connect the shell structures and create firm junctions between the surfaces. We will use the shells from the current selection for trimming bodies. Notice that now the shell surfaces are firmly connected. Let's switch to another 3D view where we have already added a simple wall segment to the design. We will adjust the shape of this wall surface by applying the Trim Elements to Roof or Shell command once again. We will use the existing shell structures for the trimming body. Let's proceed and remove the unnecessary inner part of the wall as well. We will use the same method as before, but now the trimming body will be the arc structure we created at the beginning of this presentation. Here you can see the completed arcs and trimmed walls in 3D. Let's switch to another view where you can see the entire building. We can continue and create the top structure of the skyscraper using the previously described steps, story by story, using the presented methods. This 3D view presents the completed ArchiCAD model of the Chrysler Building. Please notice that the top part of the building has been created by extruded and ruled shell structures. Designed with ArchiCAD, Kotaro Ide's shell has won a number of awards in the US and Japan for its innovative approach to designing a building able to withstand a high moisture climate in a mountain resort area. This building model was created by using extruded shells. Here you can see the shell structural scheme of the design. In this short presentation, you will discover how to use the extruded shells of ArchiCAD to create a part of this building model. As you can see, this structure is made of 2 extruded shells, having slightly different shell profile polygons. The shell contours are trimmed by 2 different trimming polygons. Let's create the 2 extruded shells in the 3D window. We created 3D guides earlier to speed up the work. Let's activate the Shell tool and select the extruded shell geometry and the detailed construction method. We will start by defining the plane of the profile polygon of the extruded shell. Then we will use ArchiCAD's Magic Wand tool to define the profile polygon. We will start by tracing the red 3D guide and use this as the profile polygon of the top extruded shell. We will define the length of the extrusion vector by entering an exact numeric value to the tracker palette. Here you can see the completed extruded shell in 3D. Let's create the bottom shell in a similar manner. This time we will use the blue 3D guide to define the profile polygon. We will use the tracker palette to enter the length of the extrusion vector again. We will reposition the second shell in the 3D window by dragging it next to the previously created shell. Currently, both shells are in a vertical position, so we'll rotate them 90 degrees to the horizontal position using the free rotate option of the pet palette in the 3D window. We will define a horizontal axis for the rotation and align the rotation angle to the appearing temporary guideline. Here are the rotated horizontal shells in 3D. Let's switch to the floor plan view to define the contour of the extruded shells. Here you can see two previously created polylines. These will help our work. Let's select the top shell first. This is the one with the reddish cover fill. And activate the Define Shell Contour command from the context menu. We will use the magic wand to define the cutting polygon by tracing the red polygon. We will continue by selecting the other blue shell, activate the Define Shell Contour command, and define the blue polyline for the trimming polygon with the help of the magic wand. Here you can see both trimmed shells in the 3D window. Let's continue the design and place a circular skylight into the upper shell structure. This can be done with a simple click thanks to the advanced skylight tool of ArchiCAD. Let's open another 3D view where the entire shell scheme of the building is displayed. The shell structures in the front have been created using the previously presented steps. Let's add a curtain wall to the design. Here you can see the curtain wall structure connecting the building shapes. This was created using the curtain wall tool of ArchiCAD. The curtain walls must be trimmed to the inner surfaces of the extruded shells. This can be done in seconds. All we need to do is to select the curtain walls and all shell structures we want to use as trimming bodies, and then activate the Trim Elements to Roofs Shells command from the context menu. We will use the shells from the current selection to trim the curtain wall. As you can see, the results are immediately visible in 3D. The curtain wall structures are trimmed to the inner surface of the shells. Let's have a quick look at the completed project now. Here you can see the additional curtain wall as well as the floor slabs in the model of the terrain. ArchiCAD 15 enriches architectural forms available for designers to unleash their creative minds. As you saw in the product demo, ArchiCAD 15's freeform modeling capabilities are great to design buildings and building structures with unconventional shapes. Our current webinar was focused on the design and renovation aspects of ArchiCAD 15. ArchiCAD 15 also continues the Open BIM initiative started in previous versions. One of ArchiCAD's clear differentiating factors is its performance. ArchiCAD 15 brings major improvements here with its full 64-bit support for both Microsoft Windows and Apple Macintosh operating systems. We hope that you have found this presentation useful and will share the opinion of architects around the world. ArchiCAD, the one and only software tool designed by architects for architects, is the best model-based design and documentation solution available for architects today. Thank you very much for taking the time to watch this presentation.